Today, class, we'll be looking at section 2.8, Scientific Notation, and it is found on page 106. Please pay attention because today's lesson has more value than just your typical math lesson. You'll notice the word scientific. It might remind you of the word science, because what we're going to learn today is used in some science classes you will have later on. So please pay very close attention, because not only will we use this again this year, and in your other math classes you will use this as well, but you will also use this in classes like physics, astronomy, and chemistry. You might even use this in some of your biology classes. I'm not entirely sure if they'll cover it in there. So please pay close attention, because you will use this in a lot of different settings. First, we need a definition of scientific notation, and it's right there for you. Pause the video and copy that down if you need to, or just listen to me and write along. Either way, or do whatever you want to do. Scientific notation is written as the product meaning multiply. It is written as the product of two factors. Factors are two numbers that when I multiply together, I get another number, okay? One of the factors is greater than or equal to 1 and less than 10, meaning that it could be, it could be 1, it could be 2, it could be 7.8753, it could be 9.9999, but it can't be 10. It could be 1, but it can't be less than 1, and it can't be 10 or greater than 10, okay? The second factor, the first factor is this, the second is a power of 10. You're thinking, a power of 10, what? Powers? What are we talking about? Superheroes? No. A power of 10 is that whole exponent thing. I think you'll understand once I show you an example. So, an example like this. Let's say you were given the number, what is this? 10,000? 10,000. This is what we call standard form right here. Standard form. We could write this number in scientific notation like this, where you have 1 times, it's not an X, this is a times symbol this time, times 10 to the 4th power. You see, power of 10, 10 to the 4th power. That's what we're talking about right there. Okay, now let's look at why we do this. When you get really, really large numbers, you could end up writing them out forever and ever and ever, okay? But using scientific notation allows us to condense it down to a much smaller amount. Now, some people get confused. They think you count the zeros. That's what you do, and that tells you what you put for your exponent, right? Not quite. What you do is you go to the first number, okay? And you're going to write down all the numbers that you have right here except for the zeros. So we put the first number down, and that's just a 1. We have no other numbers besides 1 and zeros. So we put down the 1, and then we say times 10. It's always going to be times 10. Every time. Scientific notation is written with times 10. The power will change. The number up here will change. This times 10 will never change. Write that to the side if you need to, okay? Okay, and so what you do is you count all the numbers past your first number. We have 1, 2, 3, 4, and that's how you put your number right there, okay? Let's take a look at this. This is another example of scientific notation. I think at this point you can definitely see that that is a much smaller way of writing it. You could write out this big line right here, or you could write it like this. It's a lot smaller, if you notice. See, we go from this, that big, to that big. So, smaller. It's just a little bit smaller. And especially when you get into really large numbers, like in the trillions of trillions, quadrillions, and things like that, it really does help. You get into numbers that I don't even know how to call them at that point. They just get too big. Too big. All right, so what we have here is 3.25 times 10 to the 11th power. How do we get that? Okay, what you do to write in scientific notation is you go to the first number and you write down all of the numbers until you get to a a group of zeros that just keep going like this, okay? So I write down 3, 2, 5, okay? I put a decimal after the first number, okay? That's how it works. You put a decimal after the first number. We didn't do it up here because there's no point in writing 1 point because nothing comes after it, okay? Over here, we do have numbers after it. So a decimal goes after the first number. If you want, write that to the side. You then count how many numbers come after the first number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that determines your power. That's why we're raising 10 to the 11th power. All right. Hopefully you understand that. If not, we're going to do a few examples and get our hands dirty with the math. Whoa. All right, let's go. Example 1. Write in scientific notation. So here we are given 2 numbers. This number right here looks like it is 200,000. All right, so this one is easy enough. We are going to put R2, and we have no numbers after it except for zeros, so we are good. All right, so we put times 10. You should be able to put times 10. If on your group work and your homework and your test you do not put times 10, you obviously have not studied and practiced this enough. Beat this into your mind. Go times 10, times 10, times 10 is used every time in scientific notation. Okay. Now what power do we raise it to? All the numbers we count past the first one. 1, 2, 3, 4, 5. It's raised to the 5th power. We're done. That's our answer. Box it in. Congratulations. You have succeeded. See if you can remember how to do this. Pause the video. See if you can get this by yourself. If you have no clue at all, don't bother pausing the video. Just watch me work it. Oh, magic. All right. So we copy down, like I said, all of the numbers until you get to this big group of zeros that goes all the way to the end. The decimal, we must include a decimal, goes right behind the first number, like so. Okay? We then put times what? Times, no, surely not. Yes, you put times 10. Imagine that. It's like magic. Anyways, you then count how many numbers are after the first number. 1, 2, 3, 4, 5, 6, 7, 8. We raise it to the 8th power. And we're done. We're done. Okay, this is one of the simplest things we'll do all year. Honestly, if you can't, I'm not saying if you don't understand this. If you don't understand this, please in class ask questions. But I hope once you do learn how to do this, that you just do it well, because it's so easy. I'd hate for anyone to miss these kind of questions on tests because they're just so easy. It's not difficult. There's not complicated math. For crying out loud, we're just copying numbers down and putting decimals and counting. There's no math involved. Come on, people, come on. Okay, let's move on. Number 2, write in standard form. We've converted standard numbers to scientific. Now we're going to go the opposite way. Let us convert these scientific notations into standard form. Let's begin. Here I have 2.9 times 10 to the 5th power. Well, how do I do this? It's very simple. You need to write down your 2.9. It is very important that you include the decimal, because many students who do not get the answer wrong, and it is a very slight mistake. What you are going to do is you are now going to put your pencil on top of the decimal. You are going to look at the power, and you are going to move the decimal back, meaning that way, the same number of times as the power. So we have 5. So I go 1, 2, 3, 4, 5. All of my blank spaces get filled in with zeros. So my new number is 290,000. Okay? That is the new number. I recommend you take your time and carefully make the little humps like that, because you go one too many humps over and the whole answer's wrong. Whole answer wrong because you were working too quickly. It took me 5 seconds to do that. You can take 5 seconds. Like, no, I'm gonna do it in 2. Well, you're probably gonna get it wrong. So, take your time. Stop working so quickly. Okay, moving on. Here we have 6.75. Put the pencil there. Look up the power. And move the decimal that way. 10 times. 1, 2, 3, 4, 5, 6, 7, 8. Fill in each space with a 0. Copy it back down where you have 6, 7, 5, 0, 0, 0, 0, 0. Got my 0 there, 0 there, 0 there, 0 there, 0 there. Oh, almost missed a 0. Always double check. Always double check. If you don't double check, well, man, you're gonna pay for it. So, we're done. That's it for this section. It was pretty easy. I hope you understood it all, but if you didn't, watch the video again and write down your questions. I hope to see you all in class. But if the world ends, hey what? Guess what? You won't have to worry about math homework. So anyways, goodbye.